Alright, so now we're going to look at constraints and how constraints are actually different than parenting, as we saw on our first rigging lesson. So to do to do constraints, you need to be under the animation tab up here. So if you're under something else like polygon, let's say you were modeling, you need to make sure that you go under animations. And if you don't have this tab, a shortcut for that is you can just press F2, and then notice that will change to animation. And then to find the constraints, you go over here, it says constrain, push that, and then you'll see your constraints listed here. So we're going to learn about these 5 different constraints. So point, aim, orient, scale, and parent. So actually parent is different. Alright, this parent is different than the parenting we saw in the first lesson. That's a different type of parent. This is actually a parent constraint. So don't get that confused with parenting, right? The child parent type of stuff. So I'll explain how that works a little later. So I'm gonna cut this out. Every time you see these dotted lines here, you go to any other menu, you see these dotted lines here, it means you can actually cut this out as a separate window. So it's pretty neat. You can dock this over here. Just remember that they're under constraint. So that's where we're gonna find these, alright? So to learn about these constraints and how they're different from parenting, pretty much the only thing that sets them apart from each other is the stuff you'll see in the channel box and the fact that they are constrained to each other. If you remember when we were doing the parenting, you remember the child could move independently away, and then you could rotate the parent, and then the child would move with it, right? And then you can move it like way over there and it will move with it. Well, a constraint will not allow you to do that, and I'll show you how that works. So these constraints are actually used to control different types of attributes. What I mean by attributes is, for example, translation is one type of attribute, and then rotation is another type of attribute, and then you have scale, right? So these constraints will actually constrain to each of these particular attributes that we have here. So for example, let's say I want this to be the leader, right? And I want this one to be a follower. It still kind of works the same as a child-parent relationship, but it's a little bit different, and I'll show you those differences. So actually what constraining does is you'll be able to select one, and then the other one will get affected by it as well. Like I said, kind of like the child-parent relationship. So let's look ahead and see how this works. So to make the constraint, it works the opposite of parenting. Remember, parenting was child, parent, P. For constraints is parent, child, and then constraint. So I know it gets kind of confusing. I still get kind of tricked into that, but I know that constraints, you select the parent first. So this one's going to be the parent, okay? So I'm going to call this parent, and I'm going to call this child. Now this is separate from parenting in the first video. These are going to be constraints, but they still use that same vocabulary of child and parent, right? It just means that one is the leader and the other one is the follower. So this one is going to be the parent, and then I'm going to shift select the child, and then I'm going to do a point constraint. So I'm going to go into the options here, the little box, option box, and I'm going to reset settings so that you guys have the same settings as I do. And then we're not going to worry about all this stuff down here. Everything set to default works fine. The only thing that we're going to be messing with constraint settings is going to be this maintain offset. So we're going to leave this as is right now, and I'm going to close this off, and I'm going to say point. So what does that do, and why did that move to where the sphere is? So if I grab the sphere and I move this up and down, notice that the box is moving with it. right? I can move it this way, the box moves with it. I can move it this way, the box moves with it, right? So now what happens if I rotate it? If I rotate it, notice that the box is not rotating, only the sphere is. Now what happens if I rescale it? If I rescale, notice that only the sphere scales but not the box. Why is that? Well, because point constraint only connects to the translation, right? So if I look here at the box, look over here, this is the box is the child, that's the follower, right? The sphere is the leader. So if I select the box and you look over here in the channel box, you see that only the translate has these blue boxes. That's because the constraint, this point constraint, only connects the translation of that child and parent relationship, right? So if I grab the parent and I translate it in the y, in the x, and in the z, that little that box is gonna follow because the point only connects translation. Notice that rotation and scale, this is not set to blue, so that means that there is no connection there. That's why when I move it around, it moves with it, but when I rotate it, it does not rotate with it. Alright, so that's how that parent thing works, the constraint, the point constraint works. But now the other question is, why did the box move to where the sphere was? Right? How come it didn't stay there where it was? Well, the reason why it moved with the sphere was because if we look at the option, maintain offset is set to off. So if we actually checked it on before we did the constraint, then it would have worked. It would have just stayed there, but because we had it off, it actually connected the pivot point. So the pivot point of the box matched up with the pivot point of the sphere. So that's why it moved, because we had this checked off. So constraints are a little bit more difficult to undo. It's not as easy as doing a shift P as we saw with the to unparent, right? So to undo the connection, you have to go back to the outliner. Remember, window outliner, and then do a show all. And then notice here we have the child. We expand this one, and you'll see here this little exclamation mark in red. It says child point constraint, right? Remember, that's the point constraint that we added here. So to remove that point constraint, you can just select that exclamation mark that says point constraint and hit delete, and then now we have deleted that point constraint. So I can grab the parent and I can translate it, and now it doesn't move with it. So I can move this one back to its origin spot, right? So that's what happens when you do a point constraint. So let me show you another thing that happens when we do a point constraint. But now let's do the maintain offset. So I'm going to do maintain offset set to on. So select the parent, select child, and then do apply and close it. Now check this out. We still have the translation a connection with them, right? So I can select the parent, I can move it, but now notice that the box did not move to that pivot point of the sphere because we did a maintain offset. So that's another thing you guys need to learn, offset. So that's something that we're going to be using a lot when we do rigging, right? So I can rotate it, and the box does not rotate because there is no connection. Notice that the rotate is not set to blue. So it's the same thing. It's just that we did a maintain offset. I can rescale this. It does not affect it. It does not affect the child. Only when we translate this. Alright, so another thing that we need to learn about constraints, and this has to do with all the constraints. If you remember when we did a parenting, let me do a regular child parent so you can see what I'm talking about. So I'm going to grab this sphere, move it over, I'm going to make it smaller, and I'm going to duplicate this. Oops. I'm going to make this one smaller. And then I'm going to set this to 0 for each transformation. Do the same thing, press G. Notice everything is set to 0. Everything is set to 0. On this one, everything set to 0. And that one, everything is set to 0. Alright, so let me do the child parent P. So this one has a parent constraint. I'm sorry, this one is parented. This one has a point constraint to it, right? So let's look at the difference. If I move this one down and select the constraint one, and let's move this one down as well. So let's look at what happens with the regular parenting one. So these were the leaders, right? These two were the leaders, and then these two are the followers. So if I select the small sphere, which we did the child parent P, if you look here, this is still set to 0, right? As if it never moved, even though we are moving it. Select the child, everything is still set to 0. Now if I select this one has a constraint. That one does have values in here. It has a negative 0.986. So as I move this one around, this one, a constraint actually shares this value with the child. Notice the child also has negative 0.193. The parent also has negative 0.193. So you can see the difference between a parent constraint, a parent connection and a point constraint, or actually any constraint. So constraints and parenting, right? So that's the major difference between them. So as we move the constraint, the child gets the same values. As I move the parent, this parent-child the child does not get the values from the parent. So that's one of the benefits of using this child parent P for controllers when we do rigging, and then this would do later on when we do joints and stuff like that, which we'll get into that. So let's set this back to 0. Let's go into the outliner, show all, go into the child, and let's delete that point constraint. Now let's look at what the aim constraint does. Actually, for the aim, I'm going to show you what it does with the cone because it's easier for that. So I'll do create polygons. I'm going to do a cone. So aim constraint is kind of the same thing. I'm going to rotate this and then 90. And I'm going to freeze transformations. So everything is set to 0 now. So aim, the only time I use an aim constraint is when I'm rigging the eyeballs. So when you have a controller, let's say we wanted this to be the controller, and let's say this was an eyeball in our character, and the eye was looking at this controller, right? So if I move this controller up, I want this eyeball to rotate up like this and look at the controller, right? So that's actually what that aim constraint does. So if we go into the options, go to edit, reset. Remember, I'm not too worried about all these settings. The only thing I'm concerned about is the maintain offset. So again, if we do the parent, child, and then constrain them, normally if we uncheck maintain offset, it's gonna flip out to another direction. And the reason for that is because it has a different type of pull vector, which pull vector is it can get a little bit more complicated, but pretty much what you have to do is you have to come in here and you have to find the pull vector, or one of the aim vectors, I believe. It's that one. So you're gonna have to come in here and aim it yourself. So I can rotate this one. Is it 90 degrees or so? Maybe 180. So it can get tricky here to try and get this precise. So I'm gonna undo this, and I never use the aim constraint that way. So I'm gonna undo until that disappears, and I'm actually just gonna do a maintain offset, and again select the leader, select the follower, do apply, and close this. So now because we did a maintain offset, notice that this did not flip to the other side, right? So when we do an aim constraint, always make sure that you have a maintain offset checked on. And then now this one, you can move it around and check that out. The child, this one, will always aim at the parent, and it's constrained that way. So if that was an eyeball and this was our controller, we can easily have our character look around, right? So that's pretty cool. It's a pretty cool constraint that we can use. Zero that out. And that one has some of the rotations. I think when I constrained it, it moved. Let me undo. There it goes. So that's how the aim constraint works. So the only time when I use that is when I'm rigging the eyes. So Orient Constraint, this one only connects rotation. Alright, so if you remember, point constraint only constrains translation. Aim constraint, it works differently, so we don't have to worry about that. It's just has how you saw this one points to something and it aims at it all the time. Orient constraint only connects rotation. So let's go ahead and do that. So go to the option box, reset, and again I'm going to do a maintain offset because I don't want this object to move. And then I'm going to do parent, child, apply. Now what do you think this is going to do when I move the leader, the parent? If I look at the child, look here. If you look at the child, it only has that rotation connection to the parent. So if I move this, if I translate it, if I use one of these, notice nothing happens because it's not connected to a translate, right? So I can move this around however I want, nothing's gonna happen. But as soon as I go into the rotate tool and I rotate this, it's rotating with it, right? So I can rotate it this way, I can rotate it this way, and I can rotate it this way. So that constraint is only connected to the rotation axis. So even if I wanted to move this away, let's say I move this out and I rotate it, you can rotate it up there because the translate has nothing to do with that, right? But the rotational does. So if I rotate this one and I move it up and I rotate this one, it's gonna snap back to its original location because that's constraint. That is attached to that rotation axis as the parent. So this one cannot move freely in the rotate because we have that connection to the parent. So I rotate it, rotate this one a little bit, boom, you'll see it snap back because it's constraint with the rotation. Right? So let me undo this, get rid of the constraint, and show you what a parent constraint does. Let me undo it. Alright, there. So lastly, well, the scale constraint is pretty self-explanatory. Again, it's going to connect now the scale. So I can do maintain offset, select the parent, select the child, apply, close it, and then as I rescale this, obviously that one's going to scale with it. I can move it, nothing happens because it's not connected to the translate. I can rotate it, nothing happens because it's not connected to the rotate. But when I scale it, I guess it only works uniformly. I thought I would squish this way, but it doesn't. It only works when you scale it together this way. Let's see if it has a different option. Nope. But I've never really used a scale constraint because if you do the child parent P, it also scales it. So that's how the scale one works. And like I said, when we read characters, I've never really used the scale constraint. So if you guys want to use it, go ahead. And then lastly, the parent constraint. You might be thinking, well, we already saw that the point constraint connects that. We saw that the orient connects the rotate, and we saw that the parent that the scale connects this. So that pretty much takes care of everything, right? So what do you think the parent constraint does? This one actually it's very useful because when we start rigging, a lot of things actually translate and rotate, right? So if I want to move this off into some other location and rotate it, I want to be able to connect those two together. Well, actually this parent constraint, reset and make sure the maintain offset is checked to on. So grab the parent, grab the child, apply, closes. So if you look here at the child, this one actually connects both of them. You see all this in blue? It connects the translate and it connects the rotate. So now as I move this one, it's going to move with it. As I rotate it, it's going to rotate with it. But if I rescale it, nothing happens to that one, right? Because there is no rescale connection onto that one. So I can move this one back, hit 0. So that's what happens when I do a parent constraint. And then because this one has a connection with the translation and the rotate, it's not gonna allow me to move it away, because if I move it, it's gonna snap back because it already has a translation constraint to it. If I move it away, or even if I just rotate it, then I move it, it's gonna constrain back. So it doesn't matter what I do, move, move. As soon as I move the parent, boom, it constrains back. So if you remember the child parent, that one you can move the child independently, and it didn't matter what the parent did, it just let the child go on its own. But when you do constraints, it does not allow you to move the child and then move the parent, because then it'll snap this one back because it is a constraint. So let me show you one last example before your brain explodes. All this information, I know it's pretty crazy, so I'm gonna go into this constraint and I'm gonna show you how you guys can create this little rig setup when it comes to rigging. So let's say I had this controller, right? So constraints also work with controls. They work with constraining objects together. So I'm going to show you what happens when you do a constraint with a curve or a control and an object. So it's still the same idea. So let's say this was an elevator and this was our elevator control that we want to rig so that our animator can animate this controller going up and down and the elevator will follow it. So since now you have to think again logically, since elevators can only move, or in other words they can only translate, they do not need to rotate, they do not need to we're not going to worry about the aim because we're not aiming anything. It's not like an eyeball. It's not rotating, so an orient constraint won't work with it. And we're not going to scale the elevator. A parent could work because remember the parenting connects the translation and rotation, but because we're not worried about rotation, why are we going to use that one? So a point only connects translation. So when we want this elevator to move up and down, we only want the translation, right? So I can select this controller is going to be my parent, right? As I move the controller, it's going to be the parent, and then I want this elevator object as my child. So I'm going to select the parent. Well, make sure the offset is checked on, right? Select the parent, the controller, shift select the child, and hit add. And now notice we have a connection in the translate. So if I grab this controller, I can now move it up, and the animator can move this up and down. He can even move it like this, but if he's a good animator, elevators don't do this. They don't go forward or sideways. So it depends on the animator how he wants to move it. So that is how you can use that point constraint. And again, I was going to use the same thing here that I did with the aim, but you guys already know how to do the aim. So make sure the maintain offset is checked to on, select the parent, select the child, and add it. And then now as you move the controller, this little cone, you can see how it's pointed, will always follow where I move this controller. So again, these constraints work with curves and objects, like you saw with the others. So it doesn't always have to be just objects. It can be objects and controllers working together. And then this one, let's say we had a vehicle and we wanted to rig this so that when I rotate this, when I rotate the controller, right now I'm rotating the controller, but you probably can't see it. So let me make it more obvious so you guys can see when I'm rotating this. I'm just going to select these. I'm going to move it like this. Press F8. Nope, guess not. So as I rotate this, right, the wheel is not turning, and I want this wheel to turn with the controller, right, but nothing's happening. So I need to do a constraint from this controller to this tire here. So how do we do that? Remember, point constraint will only connect translation. Aim constraint will aim at an object. Orient constraint will do rotation. So that's the one we want. So let's open up the option box, make sure maintain offset is on, select the controller, select the tire, hit add. Now as I select the controller, I can rotate this and the tire will rotate with it. Right, so that's what I want to do. Now I made it so that this brake doesn't rotate with it, because in a real car the brakes don't rotate with the tire. So that's what would happen. Alright, so that's pretty much it for the constraints, and that's what we're going to be using when we start adding controllers to the bones. So we typically constrain the controllers, as we have here. We constrain the controllers to the joints or to the bones in the character, and then the parenting is done, the child parent is done with controllers to controllers. So we'll see that once we get into rigging our first character. Alright, so check out my YouTube channel, Animation Methods on YouTube, or you can check me out on my website, animationmethods.com, where I have the rigging book now available, and I also have an animation book, and I also have more tutorials organized on my website. So you guys are welcome to check it out. Alright, so I hope you guys learned what constraints do, and the previous video what parenting does and how they're different. Alright, catch you later.